Dear students, today we will see the next algorithm, that is to find smallest divisor of an integer. The smallest divisor of an integer is very straightforward method. Every number is divisible by 1. So we can start from 2. We can divide the given number starting from 2 and in ascending order, that means 2, 3, 4 up to n, and then we can take the smallest divisor. That means we can divide it by 2, we can find out, we can divide it by 3, we can find out. By that way, we can find out the smallest divisor of a number. But it needs more iteration. Okay, if the number is not divisible by 2, 3, 4, okay, then the more number of iterations are required. Okay, and if it is a bigger prime number, then it needs more number of iteration. So that's why it's not a efficient method. And to make this method efficient, there is one more technique, okay, that we will see here. So all exact divisor of an integer are paired. That means there may be pair of integers when we take one number. Maybe for example, if you take 24, it is having following pair of divisors, like it is having like 2, 3, 4, 6, 8, 12, and each divisor has a pair. You can see like 2 is paired with 12, 3 is paired with 8, 4 is paired with 6. Okay, so that means here 24 divided by 2, because since the 24 is the number, for that we have to find out the smallest divisor. 24 divided by 2 is 12. That means 2 and 12. 12 2 is 24. So both are paired. When you are finding 2, that will be like 2 12 is 24. And if you are taking 12, 12 2 is 24. Both are paired. And 2 and 12 are the smaller and bigger factors of 24. Since the 12 is the biggest factor, 2 is the smallest factor. Same way, 3 and 8 are paired. Since 24 divided by 3 is 8, so 8 3 is 24. That's why 8 and 3 are paired. So here we can see small factor and big factor. That means 2 is the smallest factor, then 12 may be the big factor. And if you take 3 as small factor, the 8 may be the big factor. If you take 4, then 6 may be the big factor. That means both are paired. And here we can see that the smallest divisor 2 is paired with largest divisor 12. And if the integer is 30, so you can see divisor of 6 is paired with 6 itself. If you are taking 36 as a number instead of 24, then 6 6 is 36. Okay, even that is available. 18 2 is 36. 18 is the biggest factor, 2 is the smallest factor. In general, we have to consider only less than or equal to the biggest or smallest divisor to find out the smallest. Okay, maybe for example, if you are taking 24, so less than 6 may be a factor, you can see here. If we are taking 24, less than 6 may be the smallest factor. So that means one concept is, to find out the problem, we can take square root of n, square root of given number. All smaller divisors of an integer are less than square root of n, less than square root of n. So here we can see, if n is an even number, then its smallest divisor is 2. As you know, for the even number, we can take smallest divisor as 2 directly. But if you consider odd numbers, then n is the smallest divisor of n, then it is a prime. Okay, In the odd number, there may be some prime numbers. Then 1 is the smallest divisor of that prime number. The 2 is the only one prime number which is not odd. All other numbers, prime numbers, are odd numbers. Okay, so just we will see algorithmic steps. First, we will take the integer n to find out the smallest divisors. If n is even, then 2 is the smallest divisor. We can treat directly. If n is even number, then the 2 is the smallest divisor of that number. Otherwise, you have to compute r is equal to square root of n. Just find out the square root of n and take it as r. Initialize divisor d is equal to 3. Since it is not divisible by 2 means it may be an odd number. Initialize divisor d is equal to 3. While not an exact divisor and r not equal to square root of n, okay, then we will take the loop while not an exact divisor and r not equal to square root of n, generate next divisor d in odd sequence by d equal to d plus 2. That means it is not divisible by 2. Then we will come to the else part and then we will try to find out the square root. Okay, and we will take the divisor as 3. While not an exact divisor, okay, if it is not divisible by 3, not an exact divisor and r not equal to square root of n, then generate next divisor d in odd sequence by taking d equal to d plus 2. That means 3 plus 2, that is 5. That means we will start dividing by 5. Otherwise next 7. Okay, we will continue. If d is exact divisor, d not equal to n, then d is the smallest divisor of n. If d is exact divisor, if these things are not happening, okay, even this is here we are not finding, even here we are not finding, then we can say that d is exact divisor and d not equal to n, then d is the smallest divisor of n, else n is prime. Okay, that means directly we can print the en. So this is the simple concept of finding the smallest divisor of given number. So we can see just small program. So we need math.h since we need square root. So we took one function here, smallest divisor int n. That means in the main we took int n, printf, enter a number, scanf %d ampersand n. Then we are passing this n value to the function printf smallest divisor of given number %d is equal to %d. Then it is n comma smallest divisor n. Okay, then we are passing this number to smallest divisor function. So smallest divisor, maybe for example 24. Okay, now the 24 comes to the smallest divisor function. Int I, for I is equal to 2, I less than or equal to square root of n, square root of 24 plus plus I. If n mod I equal to 0, if n mod I equal to 0, that means 24 is divisible by 2, okay, n mod I, return I, okay, print that number, okay, and again in the same way continue the loop, okay, to find out the next factor. By that way you can generate all the factors one by one. Okay, so here we are returning the factor. Okay, so when the factor is generated, it will return I. So for the 24 directly it will return 2, and it will display. Okay, so if you are taking 36, again it will return 2. If you are taking any prime number, okay, so it will not take this one, directly it will return n. Okay, the given number it will return if it is a prime number, since it is divisible by only one and that number itself. That is the concept here. Okay, and as per the algorithm, the number is smaller than square root of given number. On that basis, we will try to find out the smallest divisor of a number, and it is taking less iteration compared to the normal method. Next is GCD. So greatest common divisor, and the greatest common divisor method was given by Euclid, okay, and the Greek scientist Euclid, and even it is called as Euclid's algorithm or Euclidean algorithm. And it is an efficient method to find out the GCD of two numbers, and it is the oldest method. So Euclid was there in 300 BC, nearly 2300 years back. The GCD of two integers x and y is the largest integer that divides both x and y without leaving a remainder. The GCD of two integers x and y is the largest integer that divides both x and y without leaving a remainder. And you already know about GCD concept, greatest common divisor. If I take 10 and 5, maybe the 10 is divisible by 5 and even the 5 is divisible by 5, I can say that the greatest common divisor may be 5. Okay, and even this GCD is called as GCF, greatest common factor, HCF, highest common factor, GCM, greatest common measure, and HCD, highest common divisor. There are different names of GCD. Okay, remember. And the key idea of this GCD concept is, by this GCD concept, Euclid says that it is a principle of greatest common divisor of two numbers does not change if the larger number is replaced by its difference with the smallest number. For example, if we take 20 and 15, this 20 minus 5, since the GCD of 20 and 15 is 5, and if I take 20 minus 5, that is 15, and 15 minus 5, 10, okay, even for the GCD of 15 and 10 is 5. So that is the Euclid's principle, okay, that the greatest common divisor of two numbers does not change if the larger number is replaced by its difference with the smaller number. And the algorithm for calculating GCD of two numbers is as follows. If A is equal to 0, then GCD of A and B is B, since A is not there. The greatest common divisor of 0 and B is B. If B is equal to 0, then GCD of A comma B is equal to A, since the greatest common divisor of 0 and A is A. Let R be the remainder of dividing A and B, that is A by B, assuming A greater than B. Okay, let R be the remainder of dividing A by B, assuming A greater than B. Okay, A is the bigger number, B is the smallest number. Then R is equal to, we can take that A mod B. That is first number mod second number to find out the remainder. Find GCD of B comma R. That means in the next step, we will take the second number and the remainder. Okay, since GCD of A comma B is equal to GCD of B comma R, and use the above steps again finding the R. Okay, if A is greater than B. That means A is B now and B is R. Okay, that is the concept of Euclid's algorithm. Okay, just I'll show the function. Maybe in the main A and B are passed, then GCD of A comma B is nothing but we need one variable R to find out the remainder, while A mod B greater than 0, while A mod B greater than 0, then R is equal to A mod B, then A is equal to B, B is equal to R. That means we are finding the remainder first. Then directly I can say that R is equal to A mod B. Okay, that's this step. Then we are changing B as A and R as B. And again we are taking the same step. Again A mod B greater than 0. The same steps are repeated. And at the end, when this while is over, we are returning B to the main program. Okay, so that's the concept of GCD. Okay, when we are taking two number to find out the GCD, and I'm not explaining all the steps with the analyzation method. Just you try to analyze by taking two numbers. Even you can take here int main, and in the main you can pass the, you can take like printf. Okay, and in the main you can take these steps. If A is equal to 0, then directly we can say that B is the GCD. If B is equal to 0, then directly you can say that A is GCD. Then you can call the function printf, the greatest common divisor of %d and %d is equal to double quotes close comma GCD of A comma B. Okay, then it displays the GCD of two given number other than these two steps. Okay, A equal to 0 and B equal to 0. So try to find out by taking two numbers, any two numbers, A as big number, B as smallest number, and try to analyze it. Even sometime, even in the main program, before passing, we can do one thing. We can check whether A is bigger than B or not. Okay. If it is not bigger, that means A is smaller than B, then we will exchange. We can exchange B as A as B. Even that is possible. Okay. In the main, you can do that process. First, we can check the number. We can input the number A and B. Then in the main only we can check whether A is bigger than B. If not, okay, if B is bigger than A, exchange. The swap those two numbers. A as B, B as A. Then we can find out the GCD. Okay. Next is, what is prime number? As you already know, a number that is only divisible by 1 and itself is named as prime number. For example, 3, 5, 7, 11 are prime number, and 2 is the only even prime number, as you already know. And how we can generate this prime number of given number? So commonly we will take start, initialize variable num flag equal to 1, j is equal to 2, and we will read the number from the user. If number less than or equal to 1, okay, then it is not a prime number. We can say that for that negative number there are no prime number. If number less than or equal to 1, any number less than 1 is not a prime number. Okay, then we can display num is not a prime number. Okay, directly you can go to end. Otherwise, repeat the steps until j less than n by 2 plus 1. Okay, that is nothing but j less than or equal to n by 2. Okay, even you can write in this way or j less than or equal to n by 2. Repeat the steps until it is not divisible by half of its given number. If 5.1 in the step 5, again there are smaller steps, like if remainder of number divides j, then if it is equal to 0, set flag equal to 0, go to step 6. That means if any number is divisible by j, and j, as you already know, 2. That means if any number is divisible by 2, then directly we can conclude the program by moving into step 6. Okay. Otherwise, you can, once again, you can repeat the steps or repeat the loop by taking j is equal to j plus 1. In the step 5, these two steps are there. Okay. J equal to j plus 1. Again, it will go back and again it will take the next number. Okay. And if at the end, if flag equal to 0, and it's not a prime number, since already it is divisible by 2. Number is divisible by 2 means we can directly say that it's not a prime number. Otherwise, we can say that given number is a prime number. Okay, then we can stop. So this is just simple algorithm to find out. Okay, even you can write program for it. Okay, even some people will write algorithm in this way. Step 1, take integer variable a, divide the variable a with a minus 1 to 2. If, step 3, if a is divisible by any value from a minus 1 to 2, it is not prime. Otherwise, step 4, else it is prime. Repeat the same process from step 1 to 4 for set of numbers using loop. Okay, this is simple method, simplified method. This is generalized method of algorithm. Okay. Then the pseudocode. So commonly the pseudocode is related to some program we will write. Okay, that we will call it as a pseudocode. Normally in the first sem you have seen, like, we will write the English like statement and below that we will write the pseudocode. Even in the bigger programs, like when we are writing bigger program, writing every time like the stepwise method and below that pseudocode is not necessary or not possible. So that's why we will go for everything separately. Algorithmic method, directly we will take the English like statement, and the pseudocode, directly we will take all the statements. And that how we will take, like for example, we will take the for number is equal to 1 to n given number. Then the for loop is equal to 2 to number divided by 2. Check if number is divisible by loop. Okay, that means check number divisible by all the number from 2 to number divided by 2. If divisible, return it's not prime. End if. Okay, to indicate if ends here. Then for and for. Okay, this for is over, that it indicates. Then the return prime. If there are set of numbers, we will repeat the same process for set of numbers. Okay, that means I want to generate all the prime numbers from 1 to n. Then first I have to find out each number as prime number. Then I have to repeat the same process repeatedly. That is to generate the set of prime numbers. Okay, and the whole step in the pseudocode we can see. This is the step to find out the prime number. Okay, and all these steps are repeated for n number of values. Okay, up to n, 1 to n. So each number we will take and we will try to find out the prime numbers from 1 to n. That means maybe for example n is 100. The program may be write a program to find all the or write a program to generate all the numbers, prime numbers from 1 to 100. Then we will take the program in this way. That means whatever the prime program is there, that we will repeat up to 1 to given number. The program coding to find out the series of prime numbers, that is generating prime numbers from 1 to n. So first we need two variables. One is loop to repeat the loop, okay, and another one is n to take up to number. Then int prime. Printf enter n value, scan a percentage d ampersand n. For example, we have to find out all the prime numbers from 1 to 100. Then c is equal to 1, c less than or equal to n, even you have to take c here, then c plus plus, okay. Then prime is equal to 1. We are taking prime equal to 1, just like flag, how we are taking, same way I took prime as flag. So it's not necessary that you have to take flag every time. So we took prime here, prime is equal to 1. For loop is equal to 2 to less than or equal to n by 2. That means given number divided by 2, loop plus plus. If n mod loop is equal to 0, directly prime is equal to 0. And if prime is equal to 1, so it is a prime number. Again we will try to find out the next one. That is 1 we are taking in the beginning, then again 2 we are taking, then we will repeat this loop, again 3 we are taking, then we will repeat this loop, and we will generate all the prime numbers from 1 to n. Okay, this is the method. Okay, try to analyze with the values. Take 50 and try to find out all the prime numbers from 1 to 50. Thank you, students. In the next class, we will continue with other concepts, prime factors and all. Thank you. God bless you.